Hello. Okay, so today, since I am not here, you are going to follow along just as we always do in our workbook, and we'll be doing the notes together, and whatever I'm writing down, you should be writing down, okay? So in your workbook, let's go ahead and turn to page 668. This should be lesson 11, Equal and Equivalent, part 2. And your workbook should look like my screen. We're going to do the warm-up together today because this may be new information or properties that you do not remember from last year. Okay, so we're going to talk about the associative and commutative property today with variables. Remember that word variable is just a fancy word for letters. Okay. Before we identify the property or properties shown, I want to do a little review with you, and I would also like for you to include this in your notes on this page. Okay, so maybe over here to the right, let's write the word commutative. And I want you to think of the word commute. Okay, I'm not sure if it has one M or two, to be honest. The word commute, okay, when you commute somewhere, what do you think of? And I know we don't really use that word a whole lot in our vocabulary probably, but this morning you commuted to school. When you commuted to school, you commuted by bus or by bike or by car. Your parents dropped you off, okay? So when you think of the word commute, I want you to think of the word move, okay? So when we think of the commutative property, okay, I want you to think of the word to move. So numbers or letters are moving positions, but your answer will not change. So for example, if I said 3 plus 2 is the same as 2 plus 3, that's the commutative property. They commuted, they moved spots, the answer is not going to change. No matter what, we're going to get 5. So when you think of the word commutative property, think of the word commute, to move, okay? You're moving from one spot or one location to the other, okay? And then we have the associative property, okay? When you think of the word associative, I want you to think of the word associate, okay? Again, and not a whole one word that we use in our vocab a whole lot. So when you think of the word associate, I want you to think about who do you associate with, okay? So, and this could be different depending on where you're at. So when you're at home, you may associate with one set of people or groups of people. When you come to school, you associate with different people. When you go to a practice after school, you may associate with somebody completely different. So associate is who you are hanging out with, okay? So I'm gonna write who you hang out with, or in other words, the groups that you may hang out with, okay? So I associate with my son and my husband when I'm at home, and then when I come to school every day, I associate with all of the teachers, and I associate with all of my students. And then after school, if my son has hockey practice, then I'm associating with a whole different group of adults and other parents. One moment. Okay, so when you think of the associative property, we're going to think of groupings, who you're hanging out with. So again, who you're hanging out with is going to change. One moment. Okay, so for example, if I'm doing something with the associative property, I might have, let me erase that parentheses real quick. if I have 2 plus 3 plus 4 is the same as 2 plus 3 plus 4. Okay, so the associative property normally has groupings or with parentheses. So for example, if I put a parentheses around 2 plus 3 on the left side of the equation, to make this the associative property, I may have the groupings around 3 plus 4 on the right side. Now listen, on the left, the 3 is hanging out with the 2, but on the right side, the 3 is now hanging out with the 4. Okay, I should have highlighted the 3 again. The 3 is hanging out with the 4. Okay, so the 3 is in both groups, but it changed who it was hanging out with. Okay, so commutative, they're moving spots. Associative, they're changing who they are hanging out with. Okay, so there's a little review of what you probably learned in 5th grade. Okay, which again is going to be this whole lesson. Okay, so if you look at letter A, 12 plus x is the same as x plus 12. Again, this is the same, this is just like my example that I have over here. 3 plus 2 is 2 plus 3, okay? All they did was change or move, commute, they moved positions, okay? 12 and x plus 12. So this is gonna be the commutative property of addition. There's also a commutative property of multiplication. 3 times 2 equals 2 times 3. That would be the commutative property of multiplication. Okay, let's look at B. Let's see what's happening on the next one. It's 3 times 5 times x, 3 times 5 times x. This one, again, if you look, 5 is hanging out with the 3 on the left. On the right, 5 is hanging out with the x. So it changed who it's hanging out with or who it's associating with. So we're going to call this the associative property of multiplication. There's also an associative property of addition. Okay, let's look at C. This one looks a little bit different. So we do see the groupings, we see the parentheses. And then we also don't see the exact same numbers and variables on this one. So this one's a little bit different. So if you look at the left side of the equation, you can put together the 3 and the 5 to make 8. So in other words, if we were to write this, this would be x plus 8, which does equal the same thing on the right. So on this one, we were grouping together the 3 and the 5. And then also we did rearrange the numbers in order to make the x plus 8. So this one we can actually classify it as commutative and associative. So this one we're going to say both. Okay, we commuted some of the problems around. We commuted the 3 and the 5. We combined them. So we moved them around. And then we also used those groupings. So both commutative and associative. Letter D, 12 times x is the same as x times 12. That goes back to they commuted, they moved. So that's going to be the commutative property of multiplication. And then this last one, E, we have 2b plus 5 plus 3b, and then 5 plus 5b. Again, we're going to move the 2b and the 3b. We're going to rearrange this problem to look like this. So we're going to move them around so that we can combine them. 2b's plus 3b's is 5b's plus 5. So this one, again, we're going to say the commutative property and the associative property because we're going to move them around. We're going to commute. And then we're also going to change who they're grouping with or who they're hanging out with. So we're going to say it's also the associative property. Okay, so there's a little review on the commutative and the associative property. All right, let's go ahead and start activity 1. Again, remember everything that I'm writing down, you are writing down, please. Okay, experimenting with expressions and values. Han was given the two expressions 5 plus x and x plus 5. That looks like the commutative property because they moved spots. He tried substituting 1, 2, 3, and 1,273,673 for x into both expressions. He was shocked by what he saw. What did he see? Okay, so here's what I want you to do because I want you to take good notes. I want us to write both of these down. One on the left side, 5 plus x, and then one on the right side, x plus 5. And I'm going to change colors just so I can see my problems. Okay, we're going to substitute these four numbers in for x. So if I do 5 plus 1, I'm going to do 5 plus 2, 5 plus 3, and 5 plus 1,273,673. Not sure why we're doing such a large number, but fine. And then, I'm going to change colors again. They want us to do the same thing with x plus 5. So 1 plus 5, 2 plus 5, 3 plus 5, and 1,273,673 plus 5. Okay, go ahead and please write those down. And we're going to see what Han saw. So now if I solve 5 plus 1, I get 6. If I do 5 plus 2, I get 7. If I do 5 plus 3, I get 8. And if I do 1,273,673, the 5 and the 3 make 8, so I'll get 1,273,678. Okay, on the right side, when I add 1 and 5, I'm going to get 6, 2 and 5 is 7, 3 and 5 is 8, and then this number would be 1,273,678 again, okay? So if we go back up here, it says he was shocked by what he saw. What did he see? Obviously, that it does not matter what value is substituted in for x. The sums are equal regardless of the order. Okay, now I think we already knew that, but we're going to go ahead and write something to that effect up here. Okay, so we're going to say it does, I'm just going to write doesn't matter, because this is important for the end of the lesson. It doesn't matter what value, meaning what number, we substitute for x. Okay, our sums, when we're adding, are always equal. Okay, and I'm going to put regardless of the order. Okay, so regardless of the order is important because 5 plus x or x plus 5, it does not matter. We're going to get the same answer. Okay, let's look at number 2. Han was then given another expression, 2y and y plus 3. Again, he substituted 1, 2, 3, and this large number for y into both expressions. Did Han have the same reaction that he had in problem 1? Okay, for the sake of time and just having a really annoying number, I'm going to change this 1,273,673 to 50. We get it. We want to do a large number that's not 1, 2, and 3. So for just to make things easier, I'm going to change that to 50. Okay, so we're going to do the same thing with 2y on one side and y plus 3 on the other side. Okay, so I'm going to substitute in 1 for y, 2 for y, 3 for y, and 50 for y on the left. Guys, remember, a number next to a letter means multiplication. So it's 2 times y, or 2 times 1 is 2. 2 times 2 is 4. 2 times 3 is 6. 2 times 50 is 100. And then we're going to use those same numbers for y plus 3. So we're going to substitute in 1 for y, 2 for y, 3 for y, and 50 for y. 1 plus 3 is 4, 2 plus 3 is 5, 3 plus 3 is 6, 50 plus 3 is 53. Okay. And then the question says, did Han have the same reaction that he had in problem 1? Well, obviously not, right? We did not get the same answers. We only got one that was the same here, okay? So out here, we're gonna put no. All right, his answers were not equal like they were in number 1. Okay, let's look at number 3. You are now given the expressions 2z plus 4z and 5z plus z, which means 1z. Choose some values to substitute into the expressions and record your finding. Is your reaction like Han's in problem 1 or 2? Well, let's just use the same numbers, y'all. 1, 2, 3, and 50, just to make life easy here. So on the left, we'll do 2z plus 4z. And on the right, we'll do 5z plus 1z. Okay. So on these, you're substituting in the values for both variables. So it'd be 2 times 2 plus 4 times 2. And then 2 times 3 plus 4 times 3. And 2 times, what did I say? Oh, I was supposed to do 1, 2, and 3. That's all right. 2, 3, and I'll do 5. 5 and 4 times 5, whatever. As long as we substitute 2, 3, and 5 for the next one, it'll be fine. Okay, so few things. Remember, order of operation comes into play with this problem because we have 2 times z plus 4 times z. Order of operation says that you must multiply both sets before you add, which is why I gave myself a little bit of space to do the work. So if I do 2 times 2, I get 4. And then jumping over to 4 times 2, I get 8. Then you add the 2 together, and 4 plus 8 is 12. Okay. The next one, you multiply first. 2 times 3 is 6. 4 times 3 is 12. Then add them together, we would get 18. And then on number 3, 2 times 5 is 10, 4 times 5 is 20. Add them together, we would get 30. Okay, they want to know if our answers would be the same if we still chose those same numbers to substitute in for our variables in 5z plus z. So let's do this side now. So if I do 5 times 2 plus 2, and 5 times 3 plus 3, and 5 times 5 plus 5. So I still used 2, 3, and 5 for these. Okay, you could use any as long as you used them for both to see if our answers are equal or not. Okay, 5 times 2 is 10 plus 2 would give me 12. That gives me the same answer. Let's look at the next one. 5 times 3 is 15. 15 plus 3 is 18. That one gives me the same answer. And 5 times 5 is 25. Plus 5 is 30. That one also gives me the same answer. So is your reaction like Hans in problem 1 or 2? So this one would be like problem 1, okay? So up here, the same as problem number 1. They are always equal, okay? Now, I want you to think, why would these always be equal? 2z plus 4z and 5z plus z. Okay, I'm probably getting a little bit ahead of myself, but look at this expression, 2z plus 4z. Since they both have a z connected to them, that you can combine them. If I did 2z plus 4z, you would get 6z. And over here, 5z plus 1 more z is again 6z. Okay, so either way, even though we're doing the problems a little bit differently in both of them, they both expressions is equal to 6z, so their answers are always going to be the same. Okay, I have a lot of writing on my page, and so should you. You will have a checkpoint coming up this week, so make sure you're taking good notes. Let's move to activity 2. Okay, we are going to write an equivalent expression for each given expression. So equivalent, again, this word is just a fancy word for equal expression, okay? So just like what I just went over, 2z plus 4z is 6z and 5z plus 1z is 6z. Those are equivalent expressions because they both equal 6z, okay? So here, if we're writing something equivalent to 2 times x plus 5, we could either A, use the commutative property and say, let's just flip it around, 5 times 2x. That was similar to number 1 up here, 5 plus x, x plus 5. So 2x times 5 or 5 times 2x would be the same thing. We could also write, this is the same as 2 times 5, which is 10 times x. Either one of those would give us equivalent expressions. Okay, let's look at the next one. Kind of start trying to think about these in front of myself before I write these down and see how you think another way to write these would be. Okay, so if you look at the second one, I see groupings. I'm automatically thinking about the associative property. Who are they hanging out with? So I'm going to write a times 5 times 2, and I'm going to change the groupings. Instead of 5 hanging out with the A, I'm going to have 5 hanging out with the 2. That would be the associative property. And no matter what, we're still going to get the same answers if we throw in different numbers for A. Or another way to write an equivalent expression would be combining 5 and 2 to make 10, and then doing 10 times A. Both of those would be equivalent expressions. You could write either of those and both answers would be correct. Okay, let's look at the third one. 3b plus 5b. Well, you could reverse it and do 5b plus 3b, or you could combine those since they both have b's after it, 5 times b plus 3 times b, and do 8b would be the equivalent as well. Okay, let's look at the next one. 2q plus 7 plus q. You could arrange those. You could commute any of those and use the commutative property and rearrange the problem in any way. You could also combine the terms. So 2q plus 1 more q is 3q. So we could do 3q plus 7. That would be an equivalent expression. Or 7 plus 3q. Either one would work. Okay. The next one, 5 times y. Okay. So this one, you have to actually think in reverse order. 5y, remember multiplication, a number next to a letter means multiplication. That's just repeated addition. So if you wanted to, another one that would be equivalent would be y plus y plus y plus y plus y. That would be equivalent. That would be the same as saying 5 times whatever y is, or just doing the repeated addition. Okay. The next one, 9 plus c plus 3. I could change those groupings and have the c hanging out with the 9. That would be one way to write an equivalent expression. I could also combine those constants, are what they're called, 9 and 3, to get 12 and say c plus 12 or 12 plus c. And then the last one, 5m plus 4n plus 3m. Here's something that you may not know. Since this has a different letter, you cannot combine them with the 5m and the 3m. So the only ones that you can actually combine are the ones that are identical with the m. So 5m and 3m is 8m plus 4n, because the m would have a different letter, different number substituted in for it than the n would. And then you can also reverse that and put 4n plus 8m. Okay. Alrighty. Hopefully those made some sense. I actually want us to go down here, and I'm going to choose 2 of these. And we're going to see if the expressions are equivalent, because I think this is going to help you in the very near future. Okay, we're going to test, we're going to say for each question, decide whether you think the expressions are equivalent. So yes or no. And then test your guess by choosing values for x and or y. Okay. I'm going to have us look at, let's do number 1 to start off with. And I'm just going to say that for number 1, x equals 2. So for every single x, we're going to substitute in a 2. So these are 2 different problems. We're seeing if they are equal. So if I do 2 times 2 times 2 times 2 divided by 2, okay? Okay, so if I do 2 times 2, I get 4. 4 times 2 is 8. 8 times 2 is 16. Okay, so that's going to be 16 on top divided by 2, I get 8. Okay, so 2 times 2 times 2 times 2 is 16. 16 divided by 2 is 8. Now, is that equivalent to x times x times x, or 2 times 2 times 2? 2 times 2 is 4. 4 times 2 is 8. So yes, those 2 expressions are equivalent. Okay, let's look at number 2. What if I substituted it in 2 for all of the x's? Let's do it again. 2 plus 2 plus 2 plus 2. Now we're adding instead of subtracting. Divided by 2. 2 plus 2 is 4. 2, 4, 6, 8. So I have 8 divided by 2, which is 4. Is that the same as 2 plus 2 plus 2? 2, 4, 6. No, those are not the same. Okay, so you may see some problems that look like this in the near future. And again, they look complicated, but you're just choosing a value to substitute in for the variables and checking to see if the expressions are equivalent. I would always choose an easy peasy number like 2 or 3, something very small that you're not going to make a whole lot of mistakes with. Okay. Alrighty. Let's move to the summary. Let me look at this real quick. It says, in today's lesson, you explored how to determine whether two expressions were equivalent, meaning were they equal. It would be impossible to test every possible value for a variable to know whether two expressions are always equal. So, how can you know for sure if two expressions are equivalent? One way is to use the meaning of operations and the properties of operations to show how the expressions are equal, because they can be rewritten or evaluated to look identical. Okay, so that's what we were doing with activity 2 earlier. So remember I said that the associative property can be addition or multiplication. So looking at these examples, the associative, who you're hanging out with, let's look a little bit closely at these. X plus 4 plus 6. X plus 4 plus 6. On the left-hand side, the 4 is hanging out with the X. And on the right side, the 4 is hanging out with the 6. And so that's the associative property. And then we're going to say of addition because it's all adding. The one below it, they've just changed the addition signs to multiplication signs, but the example is still the same. X is hanging out with the 4 on the left, and then it changes, X is hanging, or 4 is hanging out with 6 on the right. No matter what, you're still going to get the same answer, just the groupings are different, and that's the associative property of multiplication. And then we have the commutative property of addition, and then the commutative property of multiplication. So y plus 4 is the same as 4 plus y, or y times 4 is the same as 4 times y. Okay. Here's what I would like for you to do, and I would like for you to actually follow my instructions. I would like for you to pause the video, complete numbers 1 through 6, and then unpause the video and check your work with me. Okay, I would love for you not just to keep the video rolling right now and just copy my answers. I want you to kind of quiz yourself. Do you understand what I just went over with you? So pause the video 1 through 6 and then unpause, and you can check and correct your work. Okay? All right. Let's look at how you did. Let's start with number 1. It says, do 4x and 15 plus x have the same value when x is 5? Okay, so when x is 5, we're going to substitute in 5 for x, and over here, 5 for x, and they want to know, does it have the same value? Well, on the left, 4 times 5 is 20, and on the right, 15 plus 5 is 20, so yes. Okay, and hopefully you're showing your work and not just writing yes, because I know that one's easy enough to do in your head. Let's look at B. Are 4x and 15 plus x equivalent? Are they equivalent expressions? Explain your thinking, okay? So now you kind of have to prove it. So when we substituted in 5, it works. But does that mean they're equivalent expressions? In order to be an equivalent expression, it has to work for just more than one number. It has to work for every single number. So let's see if it works for 2. If I do 4x and I substitute in 2, I get 8. If I do 15 plus x and substitute in 2, I get 17. These are not equivalent expressions. They just happen to have the same value in letter 1a when x was 5. But they are not equivalent expressions. In order to be equivalent expressions, it has to work for any number you substitute in for the variable. So they are not equal. Let's look at 2a. Check that 2b plus b and 3b have the same values when b is 1, 2, and 3. Okay, so this is very similar to what I said the other earlier. 2b plus 1b is 3b, right? So I'm going to substitute in 1 for the b's, 2's for the b's, and 3 for the b's. And do all these. Remember, you have to multiply before you add. 2 times 1 is 2, plus 1 is 3. 2 times 2 is 4, plus 2 is 6. 2 times 3 is 6, plus 3 is 9. And then I'll also do it for 3b. Substitute in 1 and 2 and 3. 3 times 1, 3 times 2, 3 times 3. So, do they have the same values? Yes. Okay, so then for letter B, it says, do 2b plus b and 3b have the same values for all the given values? So can I substitute any numbers in for b and my answers will be the same? We already saw that they're the same for 1, 2, and 3. I can do any number, guys, and our answers will always be the same because 2b plus 1 more b is 3b. They are equivalent expressions, okay? So your answer here should be yes. So if you substitute in 7 or 8 or 9 or 3,000, you're always going to have the same value. Are 2b plus b and 3b equivalent expressions? Well, yes, that's what I just said. Okay. Alrighty. Let's look at number 3. Create your own equivalent expression. So we could have actually, obviously, different answers here. What property helps you know that they are equivalent? Okay, so because they can all be different, I guess I'll just come up with one and then you can see if you can name my property. So equivalent expressions. So if I said x plus 14 is that is equivalent to 14 plus x, what property tells you that? Well, I commuted. I moved the problem around, x plus 14, then 14 plus x, so that would be the commutative property of addition. You could have also done 14 times x, x times 14, and that would have been the commutative property of multiplication. Let me do another one. Make this one more hard. 12 plus 3a plus 4. 3a plus 16. So I have rearranged the problem. So that would be the associative property. And then I've also, that would be the commutative property because I rearranged the numbers, I commuted the numbers, and then I changed the groupings, who they're hanging out with as well. So that one, I could put the commutative and the associative property. So that's one of the tricky ones where you could do either one, or actually both. Okay. Alrighty, let's look at number 4. This one would be review back here. Claire said the value of G is the same in the following statements because they both include 30%, 90, and the variable G. Do you agree or disagree? Explain your thinking. Okay. So on the left-hand side, 30% of 90 is equal to G. 30% of 90. Remember, you change your percent into a decimal and you multiply, and she's saying that's equal to G. Okay, so if I do 30 times 90, two numbers, so 27 is G. Let's look at 4. Or not 4, sorry, yeah, the second one. On the right hand side, 30% of G is equal to 90. So she rearranged it thinking you're going to get the same thing like the associative or like the commutative property, and don't think that's going to be true. 30% would look like this, written as a decimal, of G this times G is equal to 90. Okay, so now 30% times something equals 90. So remember guys, to solve for G here, you're gonna do the inverse operation. So this time we're gonna divide by 0.30, not multiply. So that's gonna give us a different answer. If I do 90 divided by 0.30, I gotta move that decimal twice on the outside, twice on the inside then. 30 goes into 90 3 times. So that's gonna be 300. G is 300. So those are not the same. Go ahead and add those in your notes, even if you struggled on that one, because the way you set these problem up is very important, and you have to know how to do both of them, y'all. So these would be good to have in your notes, okay? One says multiply, the other says you have to divide to get your variable. Okay, let's look at 5. A television has a length. I want to draw a picture. A television has a length of L inches, a width of 28 inches, and the area, the amount of space inside, right, is 1,358. So something times 28 is 1,358 square inches. It says select all the equations that represent the relationship between the side length and the area of the television. Okay, so length times, I'm looking at A, length times 1,358 equals 28. Well, no, that doesn't make sense. Okay, length times 28 has to equal 1,358. What if we did 28 times the length? That equals, that is true. That is exactly what we just said. Length times width equals 1,358. Okay. If you do the area and you divide it by the width, 1,358 divided by 28, that will give you the length. That is true. That's just the inverse. What about 28 times 1,358 to give you the length? No. And then 1,358 divided by the length will give you 28. That one is also true. These are just the inverse. Okay? So you should have chosen B, C, and E for that one. Okay, last one, number 6, and we're going to get into this one a little bit more this week, I believe, tomorrow actually. Yes, explain how evaluating is just a fancy word for solve, the expression 4 times 200 plus 90 plus 2 can help you mentally calculate 4 times 292. Well, guys, remember, this is hard to calculate, but if you break it down into 200 and 90 and 2, you can do 4 times 200 is 800, and 4 times 90, I know 4 times 9 is 36, add a 0, and 4 times 2 is 8, and then you would just add all of those together. Okay, to be, I guess I don't have them lined up correctly, okay, but you would have 1,168, okay? So that's actually called the distributive property, which we'll get into a little bit tomorrow, but breaking down a number like 292 into a base 100 unit, a base 10 unit, and what's left over can help you do a little bit of mental math. Okay, y'all, go ahead and your sub will tell you what is next. Great job, and thank you.